Yesterday we discovered that under special circumstances, a 30, 60, 90 triangle, we were able to solve for the length of the entire triangle if we were given one side. Today we get to explore a similar idea, and that's the 45, 45, 90 theorem. Here's a diagram, and what it all means is if you have a 45, 45, 90 triangle, which in this case we do, we have a 45-degree angle, 45-degree angle, and a 90-degree angle, then we are guaranteed that the lengths of the legs, the legs here, the ones that are not across 90 degrees, the ones that are across 45 degrees, those are going to be equal. So this is congruent to this, or this length is congruent to this length. We are also guaranteed that the hypotenuse is root 2 of the legs. So in order to navigate from the side to the hypotenuse, all we have to do to the side is multiply it by the square root of 2, and that's going to guarantee that we get the correct hypotenuse. Let's go ahead and put all of this into action with a couple of examples, beginning with this one. Example 1. Observe the following 45, 45, 90 triangle with only one side given, and then determine the other two sides. For this triangle, I was given a leg. The reason I know I have a leg is because this length is across a 45-degree angle. Now for 45, 45, 90s, the legs have to be congruent, which means that the other leg S has to have the same value of 7. So here, S is equal to 7. And that corresponds with what we established here, right? The sides are equal. And now to navigate from beginning on the side to the hypotenuse, all we have to do is multiply by the square root of 2. So the hypotenuse is going to be 7 root 2. And we are done. We just solved this 45, 45, 90 triangle. Let's go ahead and do one more example. Suppose that this time we're given the hypotenuse. Now how do we get the sides? Well, we know that to navigate starting at the side and going towards the hypotenuse, all we have to do is multiply by the square root of 2. In this example, however, we're trying to go backwards. So we're going to have to divide by the square root of 2. So we get that the side is going to be 10 over the square root of 2. And that means that the other side has to equal the same thing because we have a 45, 45, 90 triangle. So the other leg is also 10 over the square root of 2. In my book, these are valid answers, but in a lot of textbooks, even in standardized testing, they want you to rationalize the denominator. So rationalizing denominators basically just means to multiply the numerator and the denominator by this root value. So here, we're going to quote-unquote simplify. So I have 10 root 2, and to rationalize the denominator, I'm going to multiply the numerator by root 2 and multiply the denominator by root 2. Again, I'm just multiplying numerator and denominator by this root value. So here 10 times root 2, we're going to get 10 root 2. And then root 2 times root 2, that's going to cancel the roots. So we're going to get 2. And then 10 divided by 2. We're going to simplify it. 10 over 2, that's 5. So we get 5 root 2. Okay, so 10 root 2 or 5 root 2 would be valid answers. This is the unsimplified version, and this is quote-unquote the simplified version, but I'll accept both. So go ahead and do the examples, and at the end I'll post the derivation of why these ratios are true.